Have you ever wondered what's going on behind the scenes when you turn on a light by flipping a switch? Hi, I'm Sonora, and today we're going to be talking about the basics of electric circuits. These are all the topics we're going to cover. First, let's look at how we annotate circuits before they've even been assembled. We start by creating a schematic, which is just a drawing of the circuit. Every circuit needs a power source, like a battery, which has a set voltage. You can think about voltage like the potential strength, and we can measure this in volts. When the circuit is closed, meaning a complete loop that connects start to finish without breaks, there will be a current running through the circuit. This is the flow of electrons that makes the additional components, or elements, of the circuit work. Measure this in amperes, or just amps. Lastly, we can add resistors to decrease the current, but this doesn't affect the voltage leaving the battery or the power source. We measure this using ohms. So now that we know the behavior of voltage, current, and resistance, you might be able to guess that the relationship can be described as V equals IR. This is known as Ohm's law, and keeping this equation in mind, we can dive straight into the differences between series and parallel circuits. In a series circuit, there is essentially one path that the current can travel. So a defining trait of these circuits is that every element receives the same current flowing in and out. It gets a little more complicated when we think about parallel circuits, where the current splits between different branches. A circuit in parallel will have elements that receive different currents flowing in and out of them. We can also have combination circuits. Before using V equals IR, we have to make sure that R is representative of all the resistors in the circuit, not just one. In a series circuit, we simply add up the individual resistances of each resistor, which is the equivalent resistance. In a parallel circuit, however, we use this equation. It's because when resistors are in parallel, the combined resistance, or REQ, will actually be lower than the lowest resistor. With this information, you can find equivalent resistance to then solve other values, like current when given voltage. You always start by reducing resistors in parallel, and here's an example of a combination circuit being simplified. Okay, so now that we got that down, let's talk about some fun elements you can add to customize your circuit. One of these elements is a switch. This is the part of the circuit within your light switch that allows you to turn it on or off. When a switch is open, there's a break in the circuit and nothing will work. When the switch is closed, everything works fine because the current can make a complete loop. Another cool element is a solenoid, which can retract and push back out using a spring, copper wire, and the electromagnetic field generated by the current. Now that we've done all the imagining and calculating of these circuits, let's see what they can actually look like in the real world. A tool that many electrical engineers use to prototype their circuits is a breadboard. They are useful to translate our circuit schematics into a real circuit. For a group project in my engineering class, we were asked to design a safe that would run on electricity. We utilized our knowledge of series and parallel circuits to create our own schematic that included the elements we talked about before, like a momentary switch, a solenoid, and 2 LEDs. Here's our circuit on a breadboard, and here's a video of us manually closing the circuit using a momentary switch. The solenoid served as our lock that kept the door shut, until this little piece of metal here was retracted while we pressed the switch. This was our final product after assembling the external pieces of the vault and integrating our circuit design to create a functioning safe. I hope you learned something interesting from this video and feel ready to create your own circuits. Thank you so much for listening.